Use the definition to find the derivative of f of x equals x squared, then evaluate f prime of 7. The first thing to do is write down the definition of the derivative. F prime of x will equal the limit as h goes to 0 of f of x plus h minus f of x divided by h. The next thing to do is to determine f of x plus h, which means to take f of x and replace all of the x's with x plus h. F of x is x squared. F of x plus h will be x plus h squared. You just replace the x with the quantity x plus h everywhere you see an x. Subtract from that f of x, which is x squared, and divided by h. This will be 0 over 0, and will continue to be 0 over 0 until we can cancel the h in the denominator with an h that factors somewhere in the numerator. In order to factor the numerator, I have to have a single expression. So the first thing I'm going to start with is by expanding out the x plus h squared. It's going to FOIL x plus h times x plus h, and then minus x squared over h. So f prime of x will equal limit as h goes to 0 of expanding by FOILing. First, x times x is x squared. Outside, x times h is xh. Inside, h times x is hx. And last, h times h is h squared minus x squared, all of this over h. Now we'll combine any like terms together. That will give us limit as h goes to 0. We have an x squared and we have a negative x squared. Those will cancel. We have an xh and an hx. Those are the same and can be added together into 2hx. And we have an h squared. Now our goal in the definition of the derivative is to get an h to factor in the numerator and cancel with an h in the denominator. And therefore, part of what would happen when you do the definition of the derivative, you always should have an h in every term in the numerator once we get it down to a single expression like this, so that the h can factor, and that will leave us with a 2x plus h if we factor the h out. And the reason we're factoring the h out is we have 0 over 0 right now, but that will disappear once we cancel that h in the denominator with the factored h in the numerator, leaving us with limit as h goes to 0 of 2x plus h. At this point we can put in a 0 for the h, and that will give us a 2x. So there's our derivative for x squared. F prime of x will be 2x. And the last thing to do is evaluate f prime of 7 by plugging a 7 in for the x, and f prime of 7 will be a 14.